Okay. Here is the overview for today. Thank you for continuing to come to class. I know week 3 is usually when attendance starts dropping off a little bit, but this looks like a solid turnout, and I really appreciate that. We'll start with the Mentimeter, and you can ask me questions that you have left over from previous lectures or admin or anything in there. And then we'll talk about visual and face perception, take our first break, talk about intramodal perception, start motor development, take a break, and then we'll talk about locomotion, which is basically just getting around, whether that's crawling or walking. So transitioning out of review. Today, hopefully, you'll get a sense of how habituation and preference paradigms work so that we can get at what infants know and what they like. And I will try to signpost a bunch of different ones for this. You'll be able to explain the limits of the early visual system and also how it changes, especially how it changes in regards to face perception. Be able to define central concepts related to perception, including visual acuity, categorical boundaries. Categorical boundaries will also come up next week, and perceptual narrowing. Elaborate environmental influences on both perceptual and motor development, and be able to sketch out, so not in like a huge amount of detail, but sketch out changes to motor abilities, including reflexes, posture, sitting, and locomotion, and then explain in slightly more detail cascades to other domains. Okay, so starting with perception. If you've taken other intro classes, you might have already gotten these definitions, but sensation is the information that your brain receives from the external world. So this is objectively what is coming in. Perception is how your brain organizes that information and interprets it. So perception is actually how we experience and encounter the world. Some of our perceptual experiences begin before we're born. So before I go into some of the more nitty-gritty stuff, I'm going to tell you a little bit about what kids already experience before they're born. So they do have touch and other like sensory motor experiences. So they can grab their umbilical cord, they suck their thumb, they practice moving. We'll talk about that a little bit. Do they taste? Yes, it seems like they actually have a sweet tooth. So researchers who were curious about this injected sugar water into amniotic fluid, and they found that fetuses consumed more amniotic fluid when there was sugar in it than if there wasn't. So it seems like fetuses prefer sweet things over not sweet things. Also sensitive to scent. So for example, when they're born, they'll orient to their caregiver's scent. It also seems like they hear things. So if you give them the choice to listen to their caregiver's voice versus their strangers, they prefer to listen to their caregiver's voice. And then, not surprisingly, the visual system is the least developed at birth, and because we went a little long on the review, I will not make you answer me, but basically because there's the least access to that information and that sensation in utero. So whereas these other things, they can already start experiencing before they're born, vision is much more limited. Like there might be some shadows and contrast, but it's definitely not defined. And also, the visual system is pretty underdeveloped. So throughout this lecture, we'll talk about a couple of general methods, both preferential procedures. So these are times where we try to figure out what newborns, older infants, et cetera, know based on what they spend more time engaging with. So like if they eat more of something, if they listen to something for longer, if they look at something for longer. So in these cases, we're taking the fact that they're looking at it for longer as a sign that they're kind of wanting it. And then habituation procedures, I'll talk about a little bit later, but they're more about what's surprising and what violates expectations. Does something seem different than something that they saw before? So beginning with this first one, I'm gonna walk you through one specific study that's like very kind of famous in intro dev world, which is the cat in the hat study. So in this one, they were interested in seeing if, based on the sounds that they were exposed to in utero, fetuses could sort of learn and then later recognize those same kinds of sounds. So they recruited 16 pregnant women. These were people that identified as women, and their fetuses and infants in the last 6 weeks of pregnancy, and had them read The Cat in the Hat out loud 2 times a day. So across the course of those 6 weeks, they were exposed for about 3.5 hours. And what they wanted to know was whether fetuses would be able to recognize and then we would interpret from that they learned the story's sound patterns. So what they did was they took newborns, sort of like around 2 to 3 days after they were born, and they measured their sucking behavior. So what I mean by this is that they had this special pacifier that they sort of like computerized that was connected to their headphones, so that based on how quickly newborns could suck, which is something that they're good at, whereas some of their other systems, like their motor system and their visual system, aren't as good yet, they could change what they heard. So for example, for some of the infants, it might have been the case that if they sucked faster, then they could hear the Cat in the Hat. If they went slower, they heard a different story. There were a couple different ones they used, but they were chosen to match the sort of like engagingness and other features of the Cat in the Hat, but different story. And then the inference is that if they suck for longer at that speed, that must be what they'd rather hear. So for example, in this case, if they suck faster, they hear Cat in the Hat for longer, we're gonna interpret or infer that that's what they preferred. With all of these preferential and habituation paradigms though, one thing you might be thinking is like, what if they just like sucking faster? What if that's just something they like doing? Whenever we have a study like this, we do something called counterbalancing. So anything that might be superficial and not what we're actually interested in, we'll have some participants get one version and others get another, so we can control for it. So in this case, some of the participants also had to suck slower to hear Cat in the Hat, and they would hear a different story otherwise. So they balanced it out, so it's not just the babies like sucking slow or fast. Yes? Both voices were people that hadn't read to them. So this would just be the story's sound pattern that they'd recognize, not the voice of the person. But there are other studies that show that they recognize voice too. Okay. So regardless of if they had to go fast or slow, what they found was that the newborns spent more time sucking at the speed that they needed to get the story that they'd heard before. So the way that they interpreted that was that when they were in utero, they could hear, and that this was enough for them to sort of like build recognition, learn about it, and recognize it and prefer it. And these slides are hopefully improved from last year, because I confused everybody with this last year. Are there any questions about this? Yes. So whenever we have something like that, where like something's on the left versus the right, or fast gives you one thing and slow gives you another thing, or it's red versus blue, anything superficial like that that we don't actually care about, we'll give half of the participants one version and the other half of the participants the opposite version. So that way, if it's just a general preference, like for the right, for example, or for faster, it should cancel out. But if they're actually doing what we're saying they're doing, it should still be in effect regardless. So half the kids had to go faster, half the kids had to go slower. Yes, so people have used these kinds of things as evidence of memory. There's also cool studies that I won't have the time to talk about with like mobiles and remembering that they can like cause effects and things like that. Okay, cool. Yes?
So is this saying that like when they were sucking, depending on the group they were in, it would then play the story?
Yes.
Okay, and then if they were sucking slower in the other group, then it would play the story.
Exactly.
The babies were sucking in a way to deliberately play the story.
Saying that it's deliberate is probably stronger than the authors would go, but like they liked it, so when they heard it, they were happier, so they did what they needed to like get what they wanted.
Yeah.
So how intentional it was would be very, not to say that you're wrong, just to say that baby people debate that a lot.
Sure.
But basically, yes.
Okay. Have they done studies like this with different types of stories?
Yeah. So.
Or is it just, what if there's something just really special?
That's fair. So in this one, I know there was one story, what was it called? They had The King, the Mice, and the Cheese, which was kind of similar in like, how like short the words were. They like matched a bunch of features between the songs, but it's not the songs, the stories. And then they also had another one where they used the words from the Cat in the Hat, but they replaced them with the dog in the fog. So it would be as close as possible to the sound of the Cat in the Hat, but not the same. And it also works with that one. So that's what they did in this study. I think there's also been other studies done more recently that I'm just not aware of. Yes. So even if they had the story that was like pretty closely matched, like the dog in the fog one, they were still matching the speed that they needed for Cat in the Hat instead. But I think what you're getting at is like, what were the specific stimuli, which is really important when you're doing infant work because you want to control all these things.
Yeah, I guess I'm just asking, like, is the child like sucking because there's a it remembers or like there's a preference for it versus like is it just the Cat in the Hat that
Oh, like the story itself is maybe just better.
Cat in the Hat or like a way that it's like that story specifically.
That's fair. That's a great question. Like it's not like the fast or the slow. It's actually just the Cat in the Hat.
Yeah, I don't know.
I think for this one that the control that they had was reasonably compelling, but like the sample size is also quite small, so you could criticize that as well. In like infant world, a lot of people just aren't convinced by a lot of these findings regardless, and I think that's also valid. Not saying that you feel that way, but just to let you know that that is like a common way people in the field feel. Yeah. I think what you're critiquing is a good thing. You're sort of like critiquing the internal validity of it, basically. Like, I think you're saying a similar thing, yeah. Yeah. It depends a little bit on what's being tested, but the authors sort of propose a linking hypothesis. So in this case, they're saying like because they're familiar with it, they prefer it. So like those two things in this case would go together. In other studies, they might only be making the argument that they recognize it or only making the argument that they like it more. And we'll look at a couple of those with phase perception. But that's sort of like a theoretical leap that the authors are making that you can be more or less convinced by. So these kinds of infant methods are really controversial because you're taking something like looking at something for longer or turning to it or like sucking faster to mean this like big, rich kind of thing, like I did this on purpose or I prefer this or I recognize this. So in the field, these are kind of the methods that we have available to us. So the people that do this kind of work argue that that's what it is. But there's a lot of work that's just starting right now where people are trying to validate these methods more and kind of like push back on critiques because I do think for a really long time we've just kind of like let these methods ride. So the best I have to offer is like they'll do what they can to control for these superficial things to make sure it's not just the story or just the speed or whatever it is. But I think it's also valid if you're not compelled by that like linking hypothesis, like that behavior reflects preference, for example. Visual perception? So this they did in the last, I don't know off the top of my head the exact week, but it's definitely later in, it's definitely at least in the second half of pregnancy. I don't know of any experiments that did exposure super early on. Like, I don't know anybody who's tried to expose fetuses at like 20 weeks and then look and see if they remember it like 20 weeks later. These kinds of effects where you see that they like quote unquote remember are very much linked to like the last like 6-ish, 4 to 6 kind of weeks. I'm gonna move on for the sake of time, but I think this is a really good thing to dissect because these methods are gonna come up a lot in the next 3 lectures. I'm gonna give you another preferential method that maybe you find the linking hypothesis a little more compelling for. So there are other researchers that were curious about flavor preferences, and they were thinking that potentially part of how you have kids in different cultures eating really different things. For example, in places where very spicy food is common, relatively young children eat spicy food without a problem. Whereas in Canadian cultural context, a lot of sort of like at least Western food, people would not be able to eat that even as adults. So their hypothesis was sort of like maybe by being exposed to certain things in utero through breast milk, that I'm already having my palate sort of like shaped by that. So they had pregnant people come into the lab and they were instructed to have carrot juice at a particular point in time and then not at all at other times. So they had one group of people that for the last trimester, so the last 3 months-ish of pregnancy, drank carrot water every day regularly. And then after the child was born, only water, no exposure to carrot flavor. They had another group where they did the opposite, so no carrot exposure whatsoever. And then child's born for the first 3 months, they're exposed to carrot flavor. And then they had a control group, no carrot flavor at all, just water. And this way they could test not just if exposure would affect preferences later on, but also if the exposure had to be sort of like during lactation, when kids were already born, if it could be further back in time. And then they tested them 6 months when they typically introduce solid foods to kids. So usually it's safe to introduce foods to kids once they can sit up independently, and that happens around 6 months. So when they were tested, it had been months for all of them since they'd been last exposed, and they had 3 different dependent variables. One was the number of negative facial expressions that they made, because these are common when trying new food, even if they don't dislike the food. Maternal perception, so if the parent thought that they were enjoying, and then they measured the actual intake. So the intake is the best sort of like preference variable. They had these like high chairs with a tray. They measured the weight before, measured the weight after to see how much they consumed. And they had carrot cereal. So it was like cereal that they'd soaked in carrots versus like water. And what they find is that being exposed to it before, so here you have the 2 carrot bars. So this is carrots, then water, water, then carrots, water, water, control. So these darker bars are the carrot ones. Whether it was before they were born or after, being exposed to flavor shaped all of these variables. So that suggests that they're already processing input, that they're getting gustatorily, even in utero, and that it does shape their preferences. And this paper then goes on to talk about culture-specific flavor preferences. So we use the sucking, and here you have a more behavioral measure. Usually these are less controversial in the field if you're looking at actual behavior. Sorry, there's random animations here. But one thing I mentioned is that the visual system is the least developed at birth. So for the rest of the lecture, we're going to focus on the visual system. And I will go for 10 more minutes and then give you your first break. So if we don't make it through this whole first section, that's okay. So one of the reasons is just that there's limited access to these sensation, this information. So in utero, it's quite dark. There are like shadows and lights and darks. It's not completely without stimulation, but it's pretty limited. And when newborns are born, their visual system's actually kind of like shockingly bad, and stays shockingly bad for a while. And I'll show you some pictures to help you visualize. But one thing we study is visual acuity. So that's basically how fine-grained your visual discrimination is. So for example, if you have bad visual acuity, you would be able to tell that these lines are lines, but these lines, even though they're distinct, might all like blur together and look gray to you because you can't make out those like sharp discriminations. And if you remember the cataract video from last week, you would have seen the woman with the board where they had little squares like this, that she was like flipping it and testing the kid to see if the surgery had worked. She was testing visual acuity. So for example, if you have developed visual acuity, you would see that there's a difference between these two. But if your eyesight's less developed, these 2 things would look the same to you because you can't make out the contrast.
For testing it on the baby, how would they be able to tell whether or not they could see it?
Good question. Okay, so one way is the preferential looking procedure. So just like with the sucking method, they would just look in this case at what they look at for longer. So in this case, this one where you can see the lines clearly should be more interesting to you because there's more like contrast and stuff going on than the gray one. So if they show these boards with two things on them, look to see where the baby looks. If they look for longer, they assume that that means they can tell this one has lines. And then they can do the same thing with smaller lines until basically these start to look the same for kids. And then based on this, they can sort of figure out where the limit is. So this is the way to do it with a preferential looking procedure. You can also use a habituation procedure. The way that habituation works, the idea is that you quote unquote habituate, so you kind of like, I don't want to use the word habit again. You give someone a stimulus so many times that there's no more information for them to take in from it. It becomes boring and they start looking at it less because they already kind of know what's going on. So I might show something like this to an infant for, in studies we generally do this for like up to 30 seconds actually. And then like in between, it's a new trial, you get the same thing for 30 seconds. And what you see is that each time you show them something that's the same, they look at it less and less and less. So then that would happen again. I'm probably boring you. And it usually takes like 6 to 8 trials with infants to get them to really drop off sharply, especially if you're using more interesting stimuli, like some of the stuff we'll talk about later. And then, oh my God, it's different. Or maybe you can't see it's different because these are really sharp. Or maybe this one looks different. So basically, like, these are getting increasingly bigger. So whatever one of these it is that makes the baby dishabituate, so they suddenly look at it longer, we take that as evidence that they know it's different than what they were looking at before. So they must be able to make out the lines on it because they became more interested and starting to look at it for longer. And in general, habituation procedures are a little less controversial than preferential looking because what you're doing is deliberately showing the same thing over and over again and you see the looking drop off. So then it's a little bit easier to assume that the reason their looking might go up again is that they can tell that it's different than in the case of just what they're looking at for longer when you just show it side by side like that. Yes. Oh, interesting. That's fair. Mm-hmm. Right, so if you're exposed to like relative darkness for a really long time, shouldn't that be more familiar? I don't know any studies off the top of my head about that, but it is common for newborns to sort of be like seem like they're kind of overwhelmed especially by like bright lights. And I know, especially in NICUs for kids that are still developing, that they keep things dark on purpose because it does seem to help with like development. I think for that's part of why the habituation procedure might be better evidence, because in this case, you're not sort of thinking about what they like more, but just like what is more different. But yeah, I think that is an interesting question that if you find a study about, I'd love for you to email. I'm sure there are clinical applications to that kind of an idea though. The last thing I'll talk to you about before we go on break is I told you that their visual system is like shockingly bad. I will give you some pictures to back that up. So what you have on this graph is age, and you can tell that it's not like totally linear, so there's like more measurements here in the first year than there are afterward. And this is where the adult level would be, this like dashed line that I put on it. And the one that's the mean is the one here in the middle, and the other is confidence intervals. So like break this down. A newborn, we would expect to see something like this. So it can tell really big contrasts from light and dark. You can like kind of vaguely from far away make out the eyes, not totally. From up close they could. And that might be part of why they're interested in faces, which we'll talk about. And this is why Scientists would recommend that when you're building a nursery, you have a lot of contrast to give them more stimulation and things they can look at, because sort of like pastels and things, there's no way they can make those out because the acuity is just not there. At around 4 months, you can start to see sharpness is emerging, but it's definitely still not adult-like. And then even at a year, this is what we might expect, where it's gotten quite a bit better, but it's not adult-like yet. So it's not until around, obviously there's some individual variability, so with these confidence intervals, the reason for that is that not everyone in the population is the mean. We also have people who are higher and lower. So the earliest you might expect that a kid would have adult-like visual acuity is around age 3, but somewhere between 3 to 5 would be typical. So it's not until they're pretty old that they have a visual acuity comparable to ours. And then I have a slide in here without because I know that when I upload these that it hides things under the animation, so you do have one to go from. I'm gonna give us the first break because it's right around 7:10, but I will stick around for any questions people have. Okay, so we talked about one concept related to visual perception, which was acuity. Another thing that's relevant, we're going to talk about it in the context of perception this week, but we'll also talk about it for hearing and language next week, are categorical boundaries. So in the real world, things that we perceive vary continuously. So for example, color is based on the wavelength of light. So based on how big the wavelength of light is in nanometers, you see a different color. So you can see here like what the spectrum is. So there's like a ton of different colors technically. But if I zoom in, we as people don't see we don't see this chunk here as full of all kinds of different dark blues, or this chunk here as all kinds of different greens. We see them categorically. So we don't see all these tiny little continuous variations. We see categories like dark blue and green. And researchers were curious to see if this was true of infants' perceptions too. So this was done using a habituation paradigm. So the same way that I showed you that like gray blob over and over again until it got boring, they would show a color like this cyan in the middle here over and over to infants. And then to see if they perceived color categorically or continuously, they showed 2 different test events. What's important about these colors is that on a continuous scale, they're different by the same amount. So they're both different by 30 nanometers. So if you perceive color continuously, these are just as different as each other. But if you perceive color categorically, even though one is dark blue and the other is a lighter blue, they're still blue to you, and green becomes a different color. So the hypothesis here would be, if they see color continuously, then they should look at these just as long because they're just as different. But if, like adults, infants perceive color categorically, they should look longer at this green one than at this dark blue one. And what they find is that even though these differ by the same amount continuously, that 4-month-olds look longer when it jumps the category than when it stays inside of it. So after they're habituated, they show the same thing over and over and over again. They'll look just as long at the new one as the old one. But here, when you give them the green that goes across the category, they'll look longer at the green than the one that they'd already seen before. Because it's a little confusing, I have another example of this. So these are I think are a little like more illustrative of this effect because they're a smaller difference. So again, shown the same color over and over again until it starts being boring. They've taken in all the information, they get it, you're showing them this color. And then they're shown in 2 different conditions, colors that are technically the same amount of difference, 15 nanometers on a continuous scale, but a different amount categorically. So this purple one here becomes a different category, it's no longer blue, whereas this one stays, they're both blue. And again, the idea is if they perceive color continuously, that they should look at these just as long. But if they perceive color categorically, they should look longer at the purple than the new blue. Again, that's what we see here. So even though these were closer together than the first ones I showed you, you still see the effect. Hopefully this kind of makes sense. And we'll talk about a similar example next week with basically how a word is enunciated. So summarizing all of the visual system stuff, even 4-month-olds, and some research has been done with younger kids, but I am not going to review it because it's more controversial, show categorical perception of color, which means that the way that they perceive color is just like adults perceive color. So their visual acuity might be worse, but they still see color categorically. And another thing that's interesting for people who are more in language is that before these studies were done, people were hypothesizing that maybe the way that we learn color categories is based on language or being taught. So it's not that we can't see these differences, but that because we don't have words for them in our language, that we just don't learn to pay attention to them. This suggests that it's not just that. Although there are interesting studies that show that, like, even though you perceive color categorically regardless of the language that you learn, that languages that have more standard words, for example, Russian has more words for types of blues that are considered like basic colors as opposed to like cyan or more like special colors like we might use here. People from those kinds of cultures that speak those languages with more words are better at differentiating types of blues, for example. So color, categorical perception, seems to be something that's more sort of universal, but there are nuanced differences based on language and environment. Now to summarize the whole section. So fetuses and infants have many sensory experiences from early in life, and it seems like some of those early infants' inputs can form the basis of preferences later, so like the cat in the hat or the flavor preferences. Infants' eyesight is initially very limited in the sense that they have low acuity, and when they're first born, their color perception is more limited. And it doesn't become more adult-like until about 3 to 5 years old. And much of our perception is categorical, so we don't notice minute little differences in like nanometer wavelength. We see differences where it jumps a different kind of category. I'm going to keep on tracking. One area where a lot of research into the visual system has gone is into face perception. There's a couple reasons researchers think that faces might be special or interesting. One is that infants see a lot of faces, and this is especially true before they can sit up and move around on their own because they rely on other people to move them around. So people are often like picking them up, spending time very close with them. Another is that given that their visual acuity is quite poor when they're born, but they're spending a lot of time up close with faces, it's one of the things that they get the most visual experience with and one of the things that they can actually see, especially the light-dark contrast, like your eyes and your mouth. And also, faces are more interesting than a lot of stimuli. So as opposed to like blocks or stripes, there's a lot of features on faces. They're attached to people who talk to you and give you other kinds of information and stimulation. So there's lots of opportunities to learn about faces. And also for building social relationships, it might be good to attend to faces. And there's been really cute studies done where kids basically wear like head-mounted cameras so you can see everything that they can see. And I will go back to this when we talk about motor development, because I think these studies are really cool because there are things you take for granted. So you wouldn't think that like sitting up makes that big of a difference, but when you go from seeing babies who are like basically looking at faces 100% of the time to now they can like look around the room, they can pick things up and like choose to interact with them, to now they can walk, you can kind of understand how much of their world is changing. But now we're just talking about faces. So this has been something that psychologists have been interested in for a really long time, and there's like old school methods that have also been developed to look at face perception. So for example, Robert Fance had what he called a looking chamber. So here you would present a stimulus. I see that you can't actually see where I'm circling. You present some kind of a stimulus here, and then the researcher could peek through and watch where the baby is looking to code looking time before we had like computer systems and videos to do it. So in these OG ones, the faces were these like schematic things that kind of looked like faces. So you kind of see that there's like what would be hair, like the light contrast of the eyes and the mouth. So it's similar to the light and dark patterns that infants are able to make out as newborns. And then he also showed them other kinds of stimuli that had interesting contrasts that they might want to look at to see if maybe they attended to faces and saw them as something special. And what you can see here are the different kinds of stimuli. So this was the one that kind of looks like a face. This was the light and dark contrasts. They had other things that might just be interesting, like newsprint has a lot going on, and then these were more like controls. And what you see is that at all of the ages here, so the blue is 2 to 6 months, purple is 2 to 5 days, yellow is newborns within 48 hours. For all of these color lines, the looking to the face is the longest. So like the yellow line here for circles is shorter than for face, blue is, so you can kind of see it for all of them. And there have been lots and lots of studies that have sort of confirmed this finding that newborns already prefer to look at faces to non-faces. More controversial, but I told you that in utero that they can make out light and dark. So there was a group of people that published a paper, I think it was in Nature, and this was a little bit of a big deal when it was first published, where they were arguing that maybe because faces are so important and we rely so much on people to take care of us that we're already attentive to faces in like an innate way. We don't need visual experience to teach us to attend to them. So they shined these light patterns that looked kind of like those paddles where you have like the contrast for the eyes and the mouth. And what they found was that in utero, fetuses would turn towards the side that looked more like a face than the side that didn't. Obviously, this is a bit controversial because you might not think that this is representative of a face. But just so you know, people are doing this kind of work. We will not spend too much time on this, but I wanted to let you know. Building on that critique, there's been other work that kind of looks at, I showed you these like schematics that don't really look like faces, and I told you that kids attend to them more. There have been researchers that have kind of looked at what features matter for them to look at it longer and treat it like a face. So one thing about faces is that they tend to be top heavy. So there's more things going on here where like our eyebrows and our eyes and our nose are than at the bottom where it's just our mouth. So like maybe it's not that they like can actually make out a face, but just want more things on top than bottom. So they compared these two to each other and looked to see where infants looked longer. What they find is that they do indeed look longer at the one that looks like an actual face than the scrambled one. So they can tell the difference between these, and they prefer the one that looks more like a face. And then they were like, maybe it's about the configuration. So maybe this one was weird because the stuff was in places where it's not supposed to be relative to each other. But if we keep the features but just flip it upside down, maybe now they can't tell them apart. They'll look at the one that's upright more than the one that's inverted. But in all of these, you're comparing like a proper face to one that's not a face. So what happens if you compare two scrambled versions like this where neither of them is really face-like? It's not until kids are older that they understand, that they lose interest in either of these. So until 3 months, they'll look longer at the top-heavy one over the bottom-heavy one. So being on top seems to be important. But that goes away at 3 months when they have more experience with faces, and then both of these are kind of treated as non-faces. So I think the most important thing to take away from here is that they do distinguish and look longer at things that look like real faces than things that just have some of the features of a real face. But that when they're newborns, it's not like that sophisticated. There's still some learning that comes in. We're back to preferential looking. So one thing that's also interesting to consider is if kids are having a lot of experience with faces, how does this shape the kinds of faces that they prefer or the people that they can tell apart from each other? So one thing that's been assessed with a preferential looking method is showing faces side by side. For example, if they have like the caregiver's face on one side and then random people that are sex matched On the other, it seems like relatively young infants know who their caregiver is and look longer at their caregiver's face. By 3 to 4 months, they've also done versions where they vary the sex. So on one half, there's somebody who would be considered like prototypically male, somebody who would be considered prototypically female. And they look to see which side that children look at. And for a long time, they were doing these studies with kids who had primary caregivers, their moms, and they kept finding a preference for female faces. So they kind of concluded that babies by 3 to 4 months prefer female faces. But the newer work was done where they were like, maybe it has more to do with the environment than it just being about like females or women. And for kids that are taken care of primarily by males, they prefer male faces or female faces. So it seems like what they're really learning by 3 to 4 months is to attend to the kinds of people that take care of them the most. And again, the assumption here is that they're looking at what they're interested in. But there, again, are limits to these systems. So for example, there's been work comparing perception of human and monkey faces. And what we see is that infants don't show a preference for human faces. So they will look equally long at human faces as monkey faces if they're unfamiliar. But by 3 months old, as they've had more experience with people taking care of them, that's the hypothesis, they start to attune to what's in their environment, and they would rather look at the human face than the monkey face. And the idea with this is kind of what we've been talking about with synaptogenesis and connections being made, where before you're born, there's a lot of kinds of environments that you might be put into. So being able to adapt to various kinds of environments and caretakers is helpful. So when they're born, it's sort of like non-specific, but as they get more exposure, it starts getting pruned. Connections that aren't used start going away. So far, I've been talking about preferences, but another thing that's important is being able to tell individuals apart. So like if I show you 2 different people, do you realize that they're 2 different people? If I show you 2 different monkeys, do you realize that they're 2 different monkeys? So preference is tested with the preference procedures that we've been talking about. You have like 2 side to side. There's no habituation. You're shown these things for the first time. Where do you look longer? And they've also done these studies with fragments of faces, focusing on the eyes to see if they need like the hair or whatever to help them or not. But preference is just which one do you look at more. Discrimination, so the ability to tell 2 individuals apart, is usually tested through, not usually, it's tested through habituation. So you're shown one person over and over again, you kind of gain that information, start getting bored of it, and then you're shown a new person. Does your looking start going up now that you're shown a new person, meaning that you can tell that they're a new person, or is it the same, suggesting that maybe you think it's the same thing again? So interestingly, 6-month-olds can tell 2 different humans apart, and they can also tell 2 different monkeys apart. So at this age, they no longer have a preference for, they have a preference for human faces, but they can still tell monkeys apart. But at 9 months, they start losing more sort of those connections that I said that they weren't using. So at 9 months, they can still tell 2 humans apart, but they can no longer tell 2 monkeys apart that look similar, at least. And if we as adults did these studies, we'd also really struggle with the monkey stimuli. Sorry, what? The last part of the... So for this one, each of these pictures is a different trial. So like they'd be shown this picture for, I don't know, like 30 seconds, 30 seconds, 30 seconds, and then they get either this one or this one for 30 seconds, and then the next one later. So we can compare how long they look for each of them. And if they're matched, then they couldn't tell them apart. If they're different, then they could. Or at least that's the assumption. So the key thing that all of these things are showing you, like the fact that they have no preference and they develop a preference for human faces by 3 months. The fact that they can tell faces of different kinds of individuals apart, and then they can only do it for humans at 9 months. These are all examples of perceptual narrowing. So this is where you're losing the ability to recognize or distinguish stimuli because you don't have experience with them. So your brain's kind of operating on use it or lose it. It's prioritizing building strong connections for the things you need over keeping connections open for things that you don't seem to need. Questions? Yes. Yes. So for both the human stimuli and the monkey stimuli, they have procedures to make sure that like the amount that they differ by is within a limited range. So obviously if you saw a monkey that had like a different fur color, you could tell that they were different. So these differ more in like facial features and things like that. But if you looked up the papers and saw the stimulus sets, like you as an adult would have a really hard time telling them apart, even though they're different. I do at least. Pruning, yeah. So so we think that it's happening because the synapses are getting lost. Okay, cool. The last thing I'll talk about with faces, and then we're done with faces. The one disclaimer I'm going to give before this is I'm going to use the terms own race and other race because this research was largely done on kids who are in monoracial settings. But what it really is based on what kinds of faces you're exposed to. So it's not necessary. Okay, so in kids that are in environments with low racial diversity, we see similar patterns for own race and other race faces, as I just told you with the pruning. So 3 and 6 month olds, for example, can differentiate two individuals that are both of their own race and of another race. But 9 month olds start to perform at chance for other race faces. So they can still tell apart people of their own race, but they get worse otherwise. And the reason that this matters is, again, because it depends on your experience. So if you're only being taken care of in a neighborhood where the people around you are white, like many of these kids in these studies were, then you're not exposed to faces of people who look different than sort of like your caregivers. So as you're not gaining experience with those kinds of faces, those synapses are going away, so the other ones can get strengthened and better. But there are studies with kids who are in more varied environments and you don't see these drop-offs. So any people you're regularly exposed to, you don't lose the ability to tell apart. I'm going to just keep using own and other as shorthand. So for a long time, sort of like the conventional interpretation we had of this was that by 9 to 12 months, they have lost sort of those connections, they can't do it anymore. But what researchers were curious about was maybe at this young age, like at 9 months old, they haven't lost this ability yet, but it's just that it's diminished and that it's not the default. So they're like, at this young age, is there still some plasticity? Can we turn it on in certain ways? And their hypothesis was that it was partially due to selective attention. So maybe white babies just aren't attending to faces of other races as long, so then they don't encode as much information. I'm going to try to go slowly on this because this confuses people every year, but I think this work is cool. So what they did was they used a cueing procedure to manipulate how infants paid attention. And the thing that's counterintuitive about this is a method that's been used for a really long time, especially in the neuro world. The side that has the cue on it is the one that you pay less attention to. So that seems counterintuitive. But it's basically because in this phase, before you're shown the picture, you're staring at this side of the screen for so long that your attention to it becomes suppressed, and when you get a new stimulus that pops up, you're more likely to look to the other side. So for example, in the first phase of the experiment, this was where they introduced them to the faces. So these were the ones that later would be the ones they'd seen before. These would be the people that they'd have to know that they were seeing new pictures of and not these people again. So for example, in the white non-cued condition, this is where their attention would be enhanced. So they get that cue, they stare at it while the fixation crosses there, and then when the stimulus finally pops up, they look longer at this side of the screen. And for any trials that were like this, the opposite would be true. And then this would also true for black faces on the non-Q trials. So wherever the cross is, sorry, I was trying to say what I was trying to say. So here, attention is enhanced to the white faces and suppressed for the black faces. So here, because the cross has been on this side, you want to look at the right now, whereas this face is on the left. So you'll pay less attention. So the important thing here is, based on this cueing, when they taught kids about the people and showed them their pictures, they were either increasing their attention to them or decreasing them. And then they also did the opposite. So there were trials where the cueing was reversed, so that they would have enhanced attention to black faces, decreased attention to white faces. After they were shown a bunch of these kinds of faces, attention was either enhanced or suppressed. They then had a test phase. So half of the pictures that they were shown were familiar. They were the people that had already been shown to them, and half were new people that they hadn't seen before. And this is just an example that they were shown a lot of different faces, not just 4 of them. And they measured to see for each trial, when they showed them one by one, how long did they look at them. And what we should see, if it's really that these connections are just kind of disappearing completely and that they're gone, is that regardless of what we're doing with their attention, that they'll perform better for the white faces. But if it's kind of malleable and this hasn't closed, there's still a developmental window, then increasing their attention should make it so that they're better at both kinds of cues. And that's exactly what we see. So if you look at the paper, they don't report results by race because there's no differences. They just report them based on cueing. So here, where they enhance their attention, regardless of race, they looked longer to the new ones than the old ones. And in the cases where their attention was suppressed, they looked equally long, suggesting that they couldn't tell the difference between them. So the big recap here, they manipulated attention, and by doing this, they showed that even though there's perceptual narrowing, it's not sort of like closed. There's still some time where you can still shape it, and the ability isn't gone. But as we get older and older, people do start getting genuinely worse. But that takes a while, not the first year of life. Probably not even the first 5. Any questions? Usually this one is very confusing to people. Mm-hmm. That's fair. In those cases, you don't seem to have a preference. They seem to be equally good. So for example, there was one study done in Israel where they looked at white Israeli children who had caretakers that were Ethiopian, and vice versa. And kids that were exposed to both kinds of faces, whether one was their family and the other was a community or vice versa, were equally good at telling people apart. So, but I think like maybe in the case where you're adopted and you're the only one in your environment, that might look different. But I don't know of any studies where they've looked at that. Okay. So initially, newborns appear to have a broad sensitivity to faces. They'll look at primates just as much as they look at people. They like top-heavy faces over bottom-heavy faces, even though they're scrambled and don't look like faces. But as they get older and they get more experience with faces in their environment, they're motivated to attend to those features, especially because they're having interactions with like their caregivers and their neighbors and people around them. They start to attend to features that they're exposed to regularly. So like they'll look longer at faces that match the sex of their caregiver. They're better at telling apart people whose races they're exposed to regularly than those that they're not. And the literature, it usually says own and other, but that's an oversimplification. But also what we see with the selective attention study is that even though this narrowing is occurring, there's perceptual narrowing, synaptic pruning, it's still malleable. It's not sort of like gone. And that's also true for language learning too, where even if you learn certain like speech sounds, for example, lose certain speech sounds in your first year of life. If you're exposed by the time you're like 6, you can still have native fluency. Talk about that next week. Done with visual systems, but one thing I think is just fun, and it's cool that kids can already do this really young, is intermodal perception. So this is basically how you're able to use information from one sense, like sound or visual, to make inferences about a different one, like what something feels like or whether it's hot or cold. And as adults, we're able to both integrate inputs from multiple senses to guide our perceptions, and we can make inferences about one modality from another. So here's an example of that. Hopefully it plays this week.
You have a superpower that you're probably not aware of.
That's my computer. And now it's not playing.
Temperature, or at least the ability to discern between hot and cold water just using your sense of hearing. And this is something we can test. So I'm going to pour hot and cold water from these identical jugs into these identical mugs. And it's your job to figure out which is which. And I'm going to blur the screen as well because there may be some visual cues that would tip you off one way or the other. Okay, here we go. It should have been quite easy to tell which was which. Feel free to pause the video and leave a comment with your guess if you like, but here's the answer. The first pour was cold and the second pour was hot. And the reason they sound different is because of the fact that water is viscous or thick, if you like. And the viscosity of water goes down when you heat it. This is something that's easier to see with a liquid like honey. So warm honey is more runny than cold honey. Whereas with water, it's less visually apparent. But when you pour water, the way it splashes into a cup is affected by the viscosity. And this change in the splashing of the water changes the sound that it makes because of various complex fluid dynamic reasons. What's really interesting is this is knowledge you already had due to a lifetime of hearing cold drinks and hot drinks being made.
Okay, so infants do not have a lifetime of hearing hot drinks and cold drinks, so we would not expect that from infants. But there are other experiments that have been done with infants that show that they can do this. So this is an example of one kind of stimulus.
Ah. Ah. Ah.
You can match the audio.
Ah. 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 E. 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 E.
So infants can match. We speculate based on their looking patterns that they're able to match the audio to the visual. So they'll, by 4 months old, look longer at this person who is making the mouth movements that match the sound that's being made than the person who's not. At a certain age, they're also able to do this with speaker gender. So if they hear a voice that sounds more like higher pitched, more stereotypically feminine, they're more likely to look at a woman who looks like she might be talking than a man, and vice versa. And they can also do this based on sync. So if one person is saying the exact same thing, but it's like slightly out of sync, so it's like on the wrong timing as the other person, they'll look longer to the in sync person. This research is more controversial because it's older and had a small sample, but it seems like even younger infants might be able to do this with different senses. So we talked about how sort of like sucking the mouth is more motorically developed than maybe some of the other senses. So there was a research study where they gave infants one of two pacifiers to suck, and they didn't let them see it. They just put it in their mouths. And they were two different shapes, which you should be able to feel through touch and sensation. And then they're just shown two shapes, and they'll look longer at the one that matched what they're experiencing suggesting that they can integrate that visual with that like sensory motor experience. Transitioning away from perception into motor development. This one, I have some videos I think are fun in it, so hopefully that gets us through the last hour. We will take a break. So motor development begins before birth. So when fetuses are developing, they are already moving around and practicing and doing some of the motions that they'll do later. So they're swallowing. We talked about that with like the sugar water and how they have taste preferences. They have the movements of breathing, which help develop the lungs for when they're born. And they have rest activity cycles. So actually, early on in the embryonic stage, technically there's constant movement. So it's not just happening at like certain times of the day. But at this stage, the embryo is too small, so it would not bother the person who's pregnant. They wouldn't be able to feel it. Somewhere between 10 to 20 weeks is where it becomes more periodic and where the person who's pregnant might actually start to feel like little flutters or kicks or things like that. So it's not just happening all the time, but there tend to be like periods where it's happening, periods where it's not. And then by 20 weeks to the end of pregnancy, they have a more sort of like, it's getting towards the circadian rhythm. So circadian rhythms aren't established until pretty far into life, but they have like a rough one where they're 3/4 of the time in quiet sleeping states and about 1/4 of the time moving. And one thing that's really annoying for pregnant people is that during the day when they're up and about and moving, that motion can be rocking and conducive to sleep. And then when they lay down, they're not moving anymore. That's when the fetus might move the most. So this is already happening. And there's a couple reasons. One I've already mentioned, which is practicing for time after birth. So practicing motions of eating, swallowing, sucking, breathing, developing muscles and joints. Sometimes it's responding to stimuli, so like hearing their caregiver's voice, seeing like really bright lights, like the one where they were pointing quote unquote face lights at them. Sometimes they touch themselves and they respond to that. And also there's times where there's no reason that they need to be doing it, and we take that to assume that it's just fun and the same reason we do it. If you have never been pregnant or around someone who's pregnant, fetal movement can actually be kind of extreme.
Here.
So you can really see it.
Oh my God.
Oh my
But
God. Help me, Lord.
Happening. Is he standing up in there?
I think so. Holy moly.
I guess we're stuck now.
Look at that.
One thing that I think is really fascinating is that there's a set of reflexes that you see in newborns that go away pretty quickly afterward that are kind of like fascinating and look similar to adults. I'll show you a video with them. But most of these disappear. Like one of them we'll talk about is like, if it's called the rooting reflex. So if you stroke the cheek of a baby, they'll like turn in that direction. It's thought to support nursing. Obviously that disappears by the time they get older. As adults, if somebody strokes your cheek, you don't just like snap your head in that direction. But other ones don't go away. Like we keep coughing and sneezing our whole lives. So here's a video to show you these.
Babies are born with a set of reflexes critical for survival in the outside world. Some of these reflexes are so obvious you might not think to look for them, such as the breathing reflex or the eye blink reflex. Rooting is one of the most critical reflexes. By touching 4-week-old Lily's cheek, she'll turn her head and open her mouth in preparation for nursing. Once the baby is in contact with a breast, a bottle, or even a finger, the sucking reflex takes over. Involuntary at first, the neonate will gradually gain control over sucking during the first year. Placing liquid in the mouth will induce the swallowing reflex.
In the first few weeks of life, it takes all the baby's concentration just to control these various uncoordinated reflexes. At this age, feeding Julia can take over an hour. After about 6 weeks, though, Julia will be a pro. There are other reflexes babies are born with that we don't completely understand. In the first 2 months, babies exhibit the stepping reflex. This is probably a precursor to walking. Watch Lily's toes fan out and curl. This is the Babinski reflex, which occurs when the bottom of a baby's foot is stroked.
You can also do it like toes curling in.
When pressure is placed on the baby's hand, you can see the grasping reflex at work. Lily's grasp is strong enough to support almost her entire body weight. For a few seconds, at least. When startled or dropped, a baby may respond with the Moro reflex. The arms fling outward and inward as if the baby were groping for support. 2-month-old Julia doesn't even need to be awake to demonstrate this reflex.
Researchers suggest that this set of reflexes were critical during an earlier stage of human evolution, perhaps dating from a time when babies had to cling to their mothers. These reflexes will disappear completely after a few months.
Okay, so a couple of these are like more basic ones that have to do with nursing, but some of these I think are ones that are more interesting where he's like faking out the baby and it like, or the fact that it looks like they're kind of like stepping and walking. And doctors will do these tests because these are considered to be a sign of good nervous system function. Yeah, so I think like these are, a lot of them are like self-evident from the name of what they are. Moro is the only one, that's the startle one, whose name isn't obvious with what it means. In the video they mentioned that they thought that these were sort of like almost like a vestigial appendage, like that it's a behavior that we have because at an early evolutionary phase it might have been useful to us. Other people have argued that like it forms the foundation of what our later skills become. So one reason people have kind of looked at why they disappear is to kind of get at this. So some people have argued that it has to do with brain development. So it's like this is our rudimentary starting phase. As we learn, our brain develops more, it becomes something different, so the reflex is gone. The trace of it's not in our brain anymore. So you can't get it to show up again no matter what. And then other people argue this more like evolutionary argument, which is the traces are there, they're just not useful to us, so we don't display these anymore. So to kind of like get at this, one thing that was observed is that heavier babies tended to crawl later than lighter babies. And the idea was that maybe similarly that your weight defects these kinds of reflexes. So the idea was if we take babies that have just stopped showing this reflex or that are on the cusp of stopping and we alter how heavy they are, maybe we can make it disappear or show up again, which would suggest that it's not just like gone in the brain, but that something about the body and being able to demonstrate it might be important. So they took babies who still showed the stepping reflex and put little weights on their ankles, and it stopped, it went away, suggesting that that like physical feature played part of it. It wasn't just the brain alone. They also did the opposite. So babies who had stopped doing it, they put them in a tank of water, so now they were more weightless, and now that they weighed less, they started showing the stepping reflex again. So it seems like it's not just that these are sort of like the starting point for other things like walking or chewing, but they are sort of like these traces that don't just go away, we just stop showing them because our body changes so that it doesn't allow us to show them anymore. For the most part, you don't need to memorize specific ages. But just to give you an overview of the order of the milestones, we'll go over some of these. But here's a slide if you want to reference it. These are based on the US, but Canada should be comparable. So one of the first things that we need to be able to like move around and control our movement is posture. So this has to do with our ability to maintain where our head and body are in space. So if you're not sort of able to like control your overall self, like your center of gravity, your core, your head, how it's connected to your body. You can't do many things like sitting, reaching. So this is sort of like the first milestone. There's very little postural control when babies are first born, but by around 3 months, they can do things like roll over and move in some ways independently. So just know the starting point is to not have postural control. You need this to be able to build the other skills. After this, babies start sitting with support, but a major advance is when they can sit independently without anybody maintaining their posture for them or with them. And this actually, even though it sounds so basic, is really hard because there's a lot of different muscle systems that have to work together. So you have to control your neck, your torso, your legs, your hips, all these things all at once. And then if you're moving your arms and like playing with things while you're sitting, you have to also do all of those things while you're doing those movements. And like I said, they'll first start sitting with support, and that does help them develop later sitting ability. And usually doctors recommend that you don't introduce food until they can sit on their own. Like I said earlier with the webcam that they put like on the kid's head, and how when they sit up, their world really changes. This is one of the first times they can really orient themselves towards things that they're excited about and they want to learn about. So they can start grabbing things and tinkering with them and learning about them. Obviously, like we said, if you're moving your arms, that requires even more motor control. And you have to coordinate like timing and reach and all kinds of things to be able to grab things. So if you're interested in motor development, there's cool work in this area. But I think for most people in this class that are not nerdy about motor development, the interesting thing is just being able to learn more and to learn more about things that you care about and not just like where your parent puts you and what things they put in your face. Because of this, or at least this is the reason that we think, there do seem to be cascades from motor development to other types of learning. So if as you're able to sit up and your motor ability improves, you're able to get more information about things that you're interested in, that could help you learn about those things. So for example, in studies where they've looked at how well their sitting ability improves from 3 to 5 months, they found that this predicts their receptive vocabulary as they get older. So that means the number of words that they understand when other people say them. And we'll get into receptive versus productive next week. If you don't know that yet, that's okay. So the kids who, here you can see on this x-axis, how quickly they learned how to sit independently. And the y is how many words they understood at 10 months and here at 14 months. You can see that the kids who had better sitting ability had bigger vocabularies 10 months and 14 months. So even though motor development and vocabulary don't seem to be like explicitly connected in the same domain, improvements in one led to improvements in the other. Beyond vocabulary, it also seems like being better at sitting and being able to explore objects more and more deeply can also help how you understand space and objects. So they used a habituation paradigm here where they showed them the same object but from different views, like it was rotating. And then at tests, they showed them an object that could be the same one, like here, like you had these triangles, these all look like triangles. Or they had a display that was impossible. So if this is what you saw during habituation, on top here, it's impossible that this view comes from the same object. And the idea is if infants look longer at these impossible ones than these possible ones, that they know something about shapes and space and how they work. And what they find is that the infants who could sit unsupported looked longer at the weird ones that weren't possible than infants that still required support sitting. So it suggests that that experience, like sitting by yourself, exploring things, helped develop your object knowledge. As children sit up and explore objects, they also start manipulating them in more targeted ways. So opposed to just like handling things or holding them, they start to be sensitive to the parts of the object that matter. So they'll spend more time like pushing buttons or turning knobs, basically doing things that do things and cause effects. And this relates to tool use. So the idea that there are objects that we use because they serve a certain function that we couldn't do with our body alone. Like a hammer allows us to hammer something in way better than we could push it in just with our hands. But to be able to use tools, we have to understand that something can be used for something else, even though they don't visually look the same. So like, there's nothing about how a spoon looks before you've learned about it and how to use it that makes you immediately think, oh, this is for food. Without knowing what a hammer is used for, you might not be able to figure out what a hammer is. So there's also sort of a challenge of figuring out not just how to use these things, but to link them to what they're useful for. So the most common type of tool use that's studied, or at least like has been studied in the most depth, is learning how to use spoons to feed themselves. So there's big changes in how they grasp them, how well they're able to coordinate it. But basically, by 9 months old, they can start grabbing them, but they still can't feed themselves with them because there's lots of other things that have to be done just right to be able to use a spoon. So it's only at around like 18 months of age that infants like grab the correct side. So just know tool use is more complicated than just like handling objects, but the kids are becoming, with age, more attuned to the parts of the toy that matter and using objects in ways that cause effects and that are effective. The last one we'll talk about is the most fun, which is actually being able to move around. I love this gift both because it's like hilarious and weird, but also I told you I cared about the active child element. I think this shows you how creative kids are. They want to move, and even if they can't do it the right way, they will find a way. I think this one's my favorite. The spider crawl's a little creepy, but so kids are motivated to move and get around and get at things. They'll find creative ways to do it if they can't do it other ways. And experience moving around teaches them a lot about like their own limits and what is and isn't dangerous. Karen Adolph is somebody who's done a ton of research in this area, and we read a paper from her this week. But I'm gonna let you just watch this video from her. Actually, you know what? I think you are owed a break right now. So I'll give us a 10-minute break, and then we'll come back to what I think is a fun video. Okay, before we keep going, I'm going to use this. A couple people have brought to my attention questions about habituation and preferential looking. So the basic idea with habituation is that they're exposed repeatedly all at the same time. So I think one thing that was confusing was that I said like the story was read over and over again while they were in utero. For habituation to work, it has to be back to back, because you might not get bored by something if you like it, if you hear it like this week and then again next week. So it's like in the same like 10-minute period, like trial after trial, they're shown the same thing and then a new thing. So the first one, the cat in the hat, is preference. So even though they were exposed in utero, they were only shown two things side by side at the same time. Did they go for the one they had stuck faster or slower? So the idea with preference is you're not shown the things beforehand. There's no familiarization or like training. You're just shown two things side by side. Which one do you want to look at more? For habituation, you have to first get bored from it, sort of like take in all the information, and then be shown a new thing. Okay, here's the video. And I don't know where I cut this off, but one thing that's important is for a long time, people sort of speculated that kids were afraid of heights, and Karen Adolph's work challenges that.
Everyone has had some kind of an experience feeling something kind of like fear of heights, and it makes perfect common sense that we shouldn't jump over the edge of a drop-off because it's dangerous, and if it's dangerous, then we should probably be afraid of it.
Probably. Exactly how and when this hypothetical fear develops makes for pretty gleeful research inside Dr. Karen Adolph's lab.
We're discovering some surprising things that are flying in the face of, how people have studied locomotion for the last 100 years.
Including what babies do and feel when they're on a ledge.
So the story about fear of heights is that there was a very, very famous classical study in developmental psychology by Gibson and Locke in 1960. that showed that human infants and infants of a number of different species will avoid crossing over an apparent drop-off on what they called a visual cliff.
As soon as the baby can move about, he can be observed in the same way as other animals.
It's a glass table, and on one side there's a checkerboard pattern surface right under the glass. The other side of the table, the patterned surface is way down on the floor. So visually, it looks like a big 3-foot drop-off. So when human babies first begin crawling, most of them will crawl over the apparent drop-off, but after several weeks of crawling experience, then they'll begin to refuse to crawl over the drop-off. And the conventional interpretation of this was that infants are avoiding the drop-off because they're afraid of heights.
She's backing away very
No, she's not interested.
She wants no part of that side.
The experiment became the shaky foundation for the myth that crawling innately teaches us to fear heights.
Babies avoid going over the drop-off because they're afraid of heights. How do we know they're afraid of heights? Because they avoid crawling over the drop-off. So as you may have noticed, the argument is circular.
As it happened, the visual cliff was a better test of an infant's depth perception, not their fear of heights. And if you look closely, you may have actually noticed that the babies don't look particularly scared.
It is a perfectly safe surface of support. So after one trial, human infants cleverly figure this out, and then they will crawl over the drop-off.
So how do you really test if a baby's scared of heights?
You can test babies at the edge of a real cliff where there's no safety glass. It's just an actual drop-off, and the drop-off can be adjustable, so it can be little or really, really big.
And why stop there? Inside Dr. Adolph's Infant Action Lab, babies are tested on a variety of apparatuses.
You can test babies at the edge of a slope, so it can be steeper, 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 crossing bridges that are wide or narrow over a surface of support, and so on. If there's no safety glass, you can test the same baby dozens and dozens of trials in the same session. And that means that you can determine for each individual infant when they think that that surface is safe and when they think it's risky within a couple of degrees of accuracy, like 2 degrees of accuracy for a slope.
Dr. Adolph has spent 25 years running tests like these, and the resulting data sets are both convincing and adorable.
Infants spend most of each trial right at the edge of the precipice. They're reaching their arm down over the drop-off. They are putting their little feet or their little hands on the bridge and taking little tiny steps at the edge. And all the while they're doing it with either neutral or positive facial expressions.
What's more surprising is how their approach changes as they learn different forms of locomotion.
So what happens is that when babies first begin crawling, they'll crawl right over the edge. Then over weeks of crawling, their responses get more and more accurate until finally they're at adult-like levels so that they can tell precisely whether a slope is safe for crawling or whether a drop-off is safe for crawling. But then the next week, when these babies stand up and face these same drop-offs, same slopes, same apparatus, now as a new walker, they walk right over the edge. So in fact, there seems to be 4 learning curves in development as babies learn to sit, learn to crawl, as they learn to cruise, and then finally as they learn to walk. So if they were afraid of heights, you should just be afraid of heights. In the rain and on a train and in a tree, you shouldn't see 4 separate learning curves.
So if babies aren't learning to be afraid of heights, what are they learning?
I think that what babies are learning over weeks of sitting, crawling, cruising, walking is they're learning to perceive the relations between their bodies and the environment.
They're discovering what's possible and what's just a little too far.
And you can learn that without feeling any sort of fear at all. In fact, Eleanor Gibson, the person who first invented the visual cliff, wrote later in her life, as a goat is peering over the edge of a steep crag, it knows not to walk off the edge. And she said, I don't think it's feeling any emotions at all. It just knows not to go. And that's what we're seeing in babies.
Who probably know not to go. Probably.
Okay, so to recap, this is the paradigm that was used for a really long time to sort of like reason about kids' depth perception, fear of heights. And the idea was that it had this plexiglass top so that it was actually safe, no kid was gonna get hurt, but it looked like there was a drop-off. And because infants initially wouldn't cross it, that was taken as evidence sort of that they were afraid of heights. Still good evidence that they perceive depth. So like based on the size of the checkered squares, they could kind of tell that there was a drop-off. But this has been challenged since then by the work that we were just shown. And basically you see that like when kids are just learning a new skill, like they've just learned how to crawl, they've just learned how to walk, they will like storm right off the edge and put themselves in like a death situation if somebody didn't catch them. So it's not that they're afraid of heights, otherwise they wouldn't do this. And the interesting thing that she shows is like, you might think like once you learn about heights the first time, like you learned about it with crawling, you might have fallen, now you don't attempt slopes that you can't do. You'll just cross-apply that knowledge now that you can walk, and even though you're new to walking, you won't storm off the sides of things. But it seems like every time they gain a new locomotor skill, that they have to sort of repeat that pattern. So kids who learn how to crawl, they no longer go down slopes that they can't, or like fall into holes. Once they start walking, they'll do the same thing. They'll like confidently walk off. And that's kind of what she said, where what they're learning isn't just sort of about heights or the environment, but their relationship of their body and what they can do to the environment. But one thing that's interesting is that they do learn this pretty quickly. So even though you saw them kind of like march off, within like a couple of weeks of learning a new skill, they stop doing that. So they do learn pretty quickly. And that brings us to this week's paper. I'm noticing that I've given you 2 papers in a row that are not experimental after the first week telling you that experiments are super important. But next week you'll have an experiment, but this one's more correlational. So what was the research question? Yes. Yes, exactly. So they were curious about how falling affects infants' learning and willingness to keep learning how to walk. And the big thing that they sort of wanted to show was like, how is it they still learn how to walk even though they're failing so much? Like if this was a reinforcement learning paradigm and a computer was learning, they'd give up. Why don't kids do that? How did they test it? Yes. So basically it was a big observational study. They both collected info from parents about like falls that they'd had in the past and things about their kid. And they also brought them into Karen Adolph's lab that's like decked out and has like motion sensors and things so that they could see a bunch of things like after they fell, what happened? Where were they spending time in the room? What kinds of objects were they handling? So I guess that gives us the IV and the DV. I will break down to more specific ones later. I guess maybe give me like 3 pieces of evidence that they found to suggest that falling wasn't like super costly for kids or didn't deter them. Very quickly, yeah. Yes, that's true. So for the vast majority of falls, like over 90% of them, neither the parent nor the child reacted and the kid recovered pretty quickly. I think there was also a hand. Yes, they fall a lot. And the like areas that they were in where they fell and the things that they were handling when they fell, they didn't start to avoid them, so that suggested that they weren't like scared or upset by it. You have one more. Oh yeah, that's a good point. So the parent reports that they looked at, where they looked to see if kids had major falls, where they were like, maybe if falling is a deterrent, then kids who had like traumatic fall incidents would be less brave than the other kids. That's not true. It seemed like they were actually more brave. Okay, so to give you the full breakdown, and I realize I didn't look at this side of the room very much, so I'm sorry about that. Big question, why are they discouraged even though they're falling so much and kind of failing all the time? And their idea was that there must be different kinds of mechanisms in place that make it so that infant falls are low cost and not that big of a deal. And the study relied on a lot of different descriptive variables rather than manipulating an independent variable. So the first thing they did was the one that we've talked about the most. Did infants falling cause concern from parents or children? What we see is the vast majority of falls, the infant didn't fuss and the parent didn't react either. And then of the other ones, like, it was usually actually the parent that was showing concern rather than the infant, or like the infant alone at least. So infant falls were super common. Somebody mentioned they happened a bunch of times per hour, but they rarely created negative experiences for the child or the caregiver. And even if they fussed, they recovered within a couple of seconds, for the most part. The next thing they thought about was that there might be ways that infants fall that make it so it's not that big of a deal. So they looked to see sort of like, more like the active child here. What did kids do while they were falling? And there were different kinds of things they did, like grabbing things, flexing their knees, that made it so that when they fall, it would be less like heavy and less forceful. So infants displayed 2 or more reactive behaviors on the vast majority of falls. And also, some things that this lab thinks about a lot is kind of like your body in space. So they also looked at what body parts were getting hit the most. And part of it's also that the way that infants fall, they're generally not hitting things that are dangerous to hit. So for example, something like falling on your butt isn't very dangerous compared to like falling on your head. And the vast majority of the time, infants are falling on like their legs, their butts, things that's not dangerous to fall on. And because of these things, combined with the fact that they're small and go slowly, here you have like, this is what the amount of force when infants fall is, actually. And then this is like a visualization of what it would be if they walked as fast and were as big as adults. And what you can see is that like, if they don't walk like us, so it's not as dangerous for them as it is for us. The last things they looked at were whether experience with falls had a negative effect on infants. So they did this both with looking at what they were doing in the room and with the parent questionnaires. So what you have here on top is the amount of time they spent walking, and here with the time that they spend with objects that they were holding or trying to hold when they fell. And the idea would be if a fall is detrimental or scary or teaches you to not try, that you should move less after it happens and avoid the things that you associate with the fall, like the toy that you were handling. And this window is removed because it's the time that it took them to recover and like get up off the ground. And what you see is that they don't really change what they're doing based on falling, and they don't avoid the things that are associated with their fall. And that's also true with the parts of the room that they were in when they fell. So they don't avoid like the corner that they were in where they fell or anything like that. The last thing they looked at was that parent report where they were like, maybe if you have a previous like traumatic fall that like really made an impact on you, that you'll move less. No, actually those infants tended to move more than the other infants. So definitely not a deterrent. So the takeaway was babies fall a lot, but it usually doesn't cause upset or distress. And this doesn't cause babies to sort of like avoid things that are associated with the fall. And there are other mechanisms associated with like them using strategies, what their bodies are like, what parts of the body tend to hit, that also help mitigate. And what they conclude is that this is a great system for learning new skills because it's low risk. And another paper that they've done was when AI was newer and a lot of people were training robots on adults walking. And they found that if you train robots on data with babies where they're like falling and also walking, that they actually learn how to walk better, which is, I think, interesting. The last thing we have to talk about is cultural variability, and I have one more video that tends to be a fan favorite, so hopefully it'll pay off that you stuck around. So in different cultural contexts, we have different child rearing practices that could affect their motor development. In this cultural context, one thing that significantly shaped motor development is concerns about sudden infant death syndrome. So especially in the 90s, there was a large case of deaths that they weren't confident on the cause of, and at the time it was called SIDS, and these tended to happen between 2 and 4 months of age. It was relatively rare, but especially now, but still a concerning number. And technically, because it's hard to tell exactly why these deaths occurred, Canada labels these as undetermined rather than SIDS now. But there were a couple of hypotheses for why this might be happening, and the main one was that it had to do with basically babies not being able to compensate with their respiration being occluded. So they were unable to breathe, and they didn't adapt by like coughing or moving to get more air, and then because they didn't have air, they would pass away. The thing that's important about this is that one thing that emerged as a response was the Back to Sleep campaign. So in North America, in both Canada and the United States, people were encouraged to have infants sleep in separate beds from their caregivers, to sleep on their back. The parents shouldn't smoke because smoking can also interfere with breathing, much like being in a bed with lots of different pillows and things that could block your mouth. A firm mattress so they didn't just like sink into it, and that if they fell asleep face first on it, they would still be able to breathe. To keep infants cool. And while these recommendations were just for sleep, one thing that happened was that even when kids were awake, their caregivers were giving them less time sort of like on their stomachs and in other positions that are helpful for developing posture and starting to move. So even though they were only told to put them on their backs to sleep, infants in both America and Canada started spending more time on their backs during waking hours. And you can see this was effective for decreasing these deaths. So that'll be one of the cultural factors that she'll talk about in this video, but there's also some things in here that people do in other cultures that might be, usually when I show these videos, that are surprising to my audience.
Experience happens in a social environment, surrounded by a culture with particular child-rearing practices. So all over Central Asia, caregivers use a gavora cradle. This cradle has no side railings, so the babies are bound to the gavora with wide straps so they don't fall out. This is a typical infant being put into the gavora. They're literally bound from their neck to their ankles, and the bindings constrain all of their movements except in their fingers and their toes. And babies are in this cradle for up to 23 hours a day. They're in there from birth until 24 to 30 months when they outgrow the gavora. And motor milestones in this culture are delayed relative to Western norms. Clothing restricts movements. Babies who wear heavy clothes achieve their prone skills at later ages than infants who wear less bulky clothes. And infants who spend a lot of time in containers like car seats, they achieve their motor skills at older ages than children who are free to move. Pediatricians used to tell parents to put infants to sleep on their tummies, prone, to prevent them from aspirating milk. But then in 1992, the American Academy of Pediatrics started the Back to Sleep campaign. So they told parents to put infants to sleep supine on their backs to avoid sudden infant death syndrome. And that led caregivers to encourage less prone time while their infants were awake. Restricted prone time while kids were awake had the inadvertent consequence of delaying the emergence of prone skills. Now, constraint can lead to delays or later onset ages. Well, exercise can lead to earlier onset ages. Here, you're watching an Armenian man exercising his infant to promote motor development. In many cultures, vigorous exercise like this is integral to child rearing. It's part of parents' expectations about what you should do, what you need to do to ensure that your child has healthy motor development. This is a film of an infant bath in Mali. And, the handling and the holding looks rough to Western eyes. But in some cultures, caregivers don't hold their babies like they're a fragile carton of eggs. Cross-cultural work and true experiments with random assignment to exercise and control groups in white US infants, experiments show that exercise accelerates the onset of skills like sitting and walking, and there's a dose response effect. So the more exercise babies get, the earlier the onset age is.
Okay, so one thing I love about this video is, one, I think it shows us how we take for granted sometimes what's normal, because in all of these cases, these kids are fine and healthy, even though several of these practices are really unfamiliar to most students that I have in this class. The other thing that's interesting with this data is that it shows that it affects their onset of motor milestones, like the first time they walk, the first time they crawl. But in the long run, things end up converging. So even though these practices are super different, by the time kids are like 3 or 4, and even younger, I just don't want to give you like an exact age because you don't need to know an exact age, they're able to sort of like run, walk, achieve the same kinds of things, despite having these really different experiences. So often when I show you cross-cultural data, I'll be showing you differences, but here what we see is that there are like many paths to the same outcome. Oh, I see what you're saying. I think the difference between this and the vocabulary is that here, eventually, as kids, they're all having experience like running around outside with their friends and doing kind of similar things. So even if there's differences sort of early on, if there's a sense of like plasticity, it catches up. With vocabulary, your environment tends to stay similar. So like if you have a smaller vocabulary at 10 to 4 months, the way that your caregivers might talk to you might be different, which can lead to these sort of like further down effects. So I think based on motor ability, I don't know what the oldest age where they find differences based on early motor ability, but it goes pretty far down the developmental line. But obviously like individual parents have the room to tailor to their kid and mitigate those things. It's not like deterministic, but correlationally, the cascade stuff tends to continue. I think part of why vocab matters, and we'll talk about this next week, is that a lot of school systems value early vocabulary size. So there's some critiques of language interventions where we focus a lot on getting kids' vocab bigger, but we overlook the fact that, for example, lower SES or kids from different cultural groups might have better narrative storytelling skills. So they know like fewer words, but they know like beginning, middle, end. But because in kindergarten, we really value the vocab, that those kids kind of get like fast-tracked and other kids get left behind. So it doesn't have to be that way, but I think with how our society is set up, that it tends to be that way. I will recap this because we're close to the end of lecture, and then I can take questions if people have them. So as a summary of the video, there are a couple different practices they talked about that accelerate motor development. So kids that get the kind of massage that you saw in the bath will begin sitting and walking earlier. Kids that get the sort of like exercise that you saw in the video begin sitting and walking earlier. One question I often get when I show these is why it's not harmful to babies, like why that doesn't lead to shaken baby syndrome. It's because it's not like a repetitive back and forth motion where the brain hits the skull. They're like smooth, large movements. And if you look it up on YouTube, like nurse training videos, not child abuse videos, you'll see that you actually have to shake a baby pretty strong. So in cases where it does happen, it's very clear that it was done intentionally by someone. This is not dangerous, it's very different. There are also things that slow motor development, so like the back to sleep campaign, insofar as kids spent more time on their backs during the day as well, not necessarily just during the night. The Gavora cradling, where they're sort of like bound most of the day. In places where it's colder and they're wearing like bulkier clothes that are harder to move in, like in Canada. But eventually kids look similar in terms of their ability to like walk, handle things. So there's a lot of things that infants have to learn to be able to coordinate their movements, and this takes time. So things we take for granted, like being able to control your neck and to like move your trunk and your arms, and like the timing that you do it with, and like how you position your hand, and whether it's like pinched or grasped or but infants come up with creative solutions. So like we saw with the crawling, that they would find ways to move around even if it wasn't like the right way to crawl. There are some reflexes that infants are born with that seem to sort of be like left over from earlier evolution. And they're really fascinating and tend to be a good sign of nervous system function, but they do fade as both the cortical connections change and their body and those like interactions between body and cognition change. And then infant motor development can cascade to other domains, like being able to sit earlier can help with vocabulary and object perception because you're getting more experience with objects you care about and manipulating them, getting information about them. And the environment you're in can shape sort of when you achieve those milestones, but doesn't necessarily affect you in the long term. Typical reminders, do the quiz, do the reading, but I'll do the next coffee hour in person again. So this one I'll do next Friday, not tomorrow, but the week after from 2 to 3 in Robarts. And if these hours aren't hitting good times for you, please seriously do just email me and let me know, like, I'd rather have it on Zoom, or I don't have class at this time. Are you free at this time? Outside of Wednesdays, I should be pretty flexible. Okay. I guess, are there any questions people want to ask with the whole class here? Okay, cool. Then I will stick around and you can ask me questions.